Hey everybody, thank you for coming out today. My name is Daniel Grotchen. I'm the Cloud Gaming Product Manager. I'm joined by Joe Hawley.
Hi everyone, I'm on the Cloud Solutions Architect team. I head up the game efforts there.
Today what we want to look at is something core to Google Cloud's culture, which is having an open ecosystem, an open cloud, and Google being defined by some of the best engineers in class. We're also going to look at the easiest solution and the most convenient solution probably for gaming, which is gaming analytics to analyze telemetry, data, user profiles, whatever you need. Now, with that, there's a lot of different ways you can handle this. You can use our entire stack. You can use things from our partners or ecosystem there. You can use even your own proprietary technology. So what we've done is have our featured partner and customer, which will come on stage and introduce himself. And during this presentation, they're going to go over how they use our stack and some parts of third-party solutions and some proprietary solutions.
Hello, my name is Mitya. I'm from Outfit 7. So I'll be explaining how we do data analytics in Talking Tom and Friends mobile games.
Hey everyone, I'm Colin Zima. I run product and analytics at a company called Looker, and we do a lot of analytics on top of all sorts of different databases, but a lot of really good stuff on top of the Google platform. So we'll show you that in a sec.
Thank you guys, and thanks for being here. So as I said, what we're looking to do is go over entire mobile analytics stack and show you how you can use it either in our platform, cross-functionally from all these different partners and customers, and see how they use it in real time. Again, what's core and fundamental to us in game development is game developers want to make games and creative experiences. And we want to give you fully managed solutions so that back-end kind of processing, you don't have to spend so much time working on. It's a way to be efficient and scale with our technology while getting you back to the core thing, which is making fundamental games. I'd like to go over some of our strategic partner. After this, we'll have Joe go over some of our strategic partners we have and customers, as well as show us kind of the inception of how we begin this data analytics stack for a data engineer. We'll then move on to how data scientists, data analysts, and business analysts might use our entire stack. So there'll be something for everyone in the crowd, I hope.
All right, hope this one works. Great. Thanks everyone for joining us today. Really happy to see everybody here. So the first thing I want to do is briefly go over what we're going to cover. So there are plenty of talks about why analytics is important for your game. That's not what we're really going to cover here. We're going to assume that you already are sold on the idea of you need analytics and the insights are valuable. So we're just going to mostly talk about actually implementing those and specifically the advantages that you can get implementing those on Google Cloud Platform. So currently we do have a really large group of some very large game companies. We're really happy to be working with all these folks. Daniel and myself are on a team that's dedicated to just working with game industry people. We have a lot of folks on our team that come from the industry and have a lot of industry experience. If any of you are in the game industry and you would like to work with us, we would be happy to have your logo up here next time that we give this talk. So for those of you who are familiar with analytics, this is a very basic analytics flow overview. This is probably really familiar. There's 4 stages to every analytics flow: ingest, storage, analysis, and visualization. So starting on the left there, your game is where you're actually going to be generating those analytic events, your telemetry events. You'll ingest them generally through a gateway. We have a lot of customers that just do this using an HTTP REST endpoint. Some of them like to use, for example, App Engine. I think later on we're going to hear from a customer who does it using Container Engine. Storage, obviously, we have a really robust object storage available, and we actually recommend that you go ahead and store all of your data directly in BigQuery, and I'll discuss that in more detail in a minute. And then the analysis portion, where you're going to have your data scientists or engineers figure out what the insights are and build some visualizations that you can then give to the development team. That's mostly going to be covered by Daniel a little later. So this is the flow from left to right. Ideally, what we want to get to is the flow back from your dev team, taking those insights, putting them into your game to increase engagement, make players happier with the things that you're doing in the game, help you monetize. So this is a reference architecture for Google Cloud Platform. Game analytics, so real-time and batch are both supported. For example, your real-time events may be coming from devices or your game client. Batch loading, it's really common to have folks send batches of analytics events after a match is finished or directly from the server that people are playing on. So for the ingest portion of that, we recommend that you use Google Cloud PubSub to take real time. And if you're going to do a batch ingest, you can just upload the file directly into cloud storage. And we have a ETL service that we call Cloud Data Flow. It's capable of taking your events both from the real time and the batch segments and putting them into BigQuery for you. You can also transform them if they need to be in a different format for the way you want to store them in your data warehouse or your data lake. We do offer a data exploration tool called Cloud Data Lab. We'll be going over that a little bit later in the talk. That's really useful for your analysts and your scientists to quickly explore the data, figure out where the insights are, use that to build the reports that you're going to send to your dev team or your business analyst people. So this is the reference architecture. If you want to get into that in more detail, we do have installations around the show called Treehouse where you can look at this and dig in a little bit on it. So the first part is the ingest. As I mentioned before, your first section of the ingest is almost always going to be either pulling it in via real time in PubSub or batch in Google Cloud Storage. So the advantage of going with a real-time flow, which you can see here uses PubSub on the left into Dataflow, and then inserts from that into BigQuery. So you get very low latency. We do have gaming customers that are able to achieve single-second latency on analytics using this exact workflow. You do get guaranteed delivery with anything that you put into PubSub. Once you've sent it to PubSub and PubSub acknowledges it, it's guaranteed that we're going to deliver that message. You can put extract, transform, and load operations, ETL stuff, in Dataflow if you need it. If you don't want to do any transforming, you just want to use that as a data runner to get the real-time stuff from the PubSub pipeline into BigQuery, you can also just issue the ETL completely. These are all fully managed services, so you don't have to choose nodes, you don't have to choose tiers. There's nothing like that. It scales to handle however many requests you send to it. So on the batch side, this is as simple as it gets. You stick a file in Google Cloud Storage, you load the file into BigQuery. There's very little cost here, very little complexity. It's asynchronous, so you can do it whenever is convenient for you. This is really low friction if you don't already have a lot of analytics event generating code in your client yet. You can start writing events directly to a local log on whatever the user's machine is, and then just upload that log to Google Cloud Storage at the end of their session. Dataflow ETL can be put in between these two, like we saw in the previous slide, if you need to transform the data. So actually storing the data, the two big options are cloud storage, and the advantage of cloud storage really is just how easy it is to use and how cost effective it is. We do have multiple storage classes. If the data that you're putting there you're not expecting to touch anytime soon, you can choose one of the storage classes that is lower cost. It's really easy to integrate uploading to Google Cloud Storage with whatever tools you're using now. If you're using another public cloud's object storage, for example, chances are the tool that you're using to upload to that will also upload to Google Cloud Storage. If you want to set a time to live, like an expiration, whenever you upload, you're allowed to do that. This is great if you want to take away some of the headache of managing or having an admin team check your objects every month to see what needs to be deleted to keep the costs in check. You can just set a time that you want it to be automatically deleted whenever you upload it. And obviously, Google Cloud Storage is a first class citizen across the Google Cloud platform. So all of our products hook into it very seamlessly. It's really easy to use. For example, if you want to upload from Google Cloud Storage into BigQuery, that batch pipeline I was showing earlier, that's very simple. This is how simple the dialog box for doing that is. All you do is choose Google Cloud Storage, put in the URL, tell it where you want it to put the data, like the name of the table, and whether you want it to append or overwrite that table, or only write if there's nothing in the table yet. And you can have it just automatically detect your schema. You can also specify that if you like. But it's super simple. So the other storage option, and the one that I prefer and that I would recommend you to do, is just go ahead and store everything in BigQuery. The reason why primarily is because the actual cost is identical. The cloud storage standard cost here has the same price per gigabyte as just storing the data directly in BigQuery. It has the same TTL support as what you have in Google Cloud Storage. A lot of the visualization tools that you folks are already going to be using and that are really popular in the game industry support BigQuery natively. And you can directly upload to it or stream to it if you choose to do that. Also, if you don't touch a table for 90 days, we cut the price in half. So we announced that last year at Next. We're really excited about that. A lot of customers really like that feature. So now if I can switch over to the demo real quickly. Okay, so I'm briefly going to go over actually what it looks like when you're querying the data that you have in BigQuery. This is mostly just to show you the scale and the speed that this operates at is really impressive. We get new customers every day that are amazed by this. So here we have some manufactured data. Shockingly, although we did talk to some game companies about it, no one was super excited to give us a bunch of their production game data to show to you folks today. So we manufactured some data so that we could show you the speed of BigQuery. So you can see these are pretty typical event telemetry analytics tables. Some of these are pretty large. Here's what a preview of it looks like, where it's going to have the user and the timestamp and the time that they did something, what their character stats looked like when they generated that event. So you can see that this particular table has 98 gigabytes and about 500 million rows. We have another table here. It's more of the same kind of data, 244 gigabytes and almost 1.3 billion rows. So yesterday, as I was playing around with this, trying to come up with a demo BigQuery query that I liked that was sort of impressive, I ran this one kind of to see if I could figure out what the limitations of the manufactured data were. This might be somewhat amusing. So this particular one, if we want to open this up a little bit, we can see here that it queried 20 gigabytes in 2.4 seconds. This is a pretty complicated query. It has 2 subqueries. It's doing some aggregation. It's doing 3 different levels of regular expression extractions. So what this has is the number of times people started a level, the number of times people completed a level, and then the completion percentage, which is obviously just calculated from those 2 numbers. This gives you a pretty good idea of what the person who manufactured this data put in as what they thought the percentage of stages completion should be, is 52% clearly. And in stage 10, they had it so that people are only completing 23% of the time, so that it would be good demo data. Again, this query's speed is really the point that I'm trying to drive home here. I have tried to write a query that would touch as much data as possible in this data set, and I could not generate a query that took more than 60 seconds. So hopefully that's reasonably fast. And yeah, if we can save questions for the end. Hopefully that's reasonably fast, show you that this is a very powerful tool. Now I'm going to have our customer come up. They're going to talk about how they actually use these tools in production environments. If we could switch back to the slides, please.
Okay, thank you for the introduction. Okay, today I'm going to be presenting with my friend Talking Tom here. What do we do at Outfit 7 regarding the analytics? So how does our pipeline look like? What data do we use? And why do we use it for? So Talking Tom and Friends is one of the most recognized mobile franchises around the world and is the top runner on all mobile app stores. That includes your Google Play stores, Apple App stores, Amazon, also Microsoft or Windows app stores. Now, how it all started? It started in 2010 when we released our first app. It was simply called Talking Tom, and you can still download it. It's a really fun app to play with. So you get a cat, you pet the cat, You can talk to the cat and it talks back in a really funny voice. So it went really viral at the time. So we didn't just sit back and relax. The next year, we released a new game called simply Talking Tom 2, which enabled the player or the user to customize Tom. So you could buy a fancy wardrobe for him, like this really cool hat that you see, or give him a toy. Now, really, for the gaming analytics, it started going on or happening in 2013 when we released our first game. So before, those were more apps, things like you would take out of your pocket and play with for 1 minute and then put it back in your pocket. Now, with My Talking Tom released in 2013, this was the first fully fledged Tamagotchi game where you take care of your cat, you feed him, and he has to take a shower every now and then, and if he's hungry, he tells you, so yeah. And with that, the gaming analytics become much more important and much more fun to deal with. Because with games, you have stuff like in-app purchases, you have more space how to target different ads, and all sorts of ways to do monetization. But we didn't stop there. During the years, we added more games to the portfolio, more talking characters, and also different games like an endless runner called Talking Tom Gold Run, and a real-time multiplayer game called Talking Tom Bubble Shooter. So the things got more and more complex, and also there was more and more data to process. So what does this mean in terms of numbers? So we have almost 6 billion downloads, and this is still growing to this day, and 348 million users playing our games each and every day. So you can imagine how much data we can collect from all of those users. So this is a number. So each and every day, a rough estimate is we stream 5 billion BigQuery rows per day. So our processing pipeline handles from 30,000 BigQuery events per second to even 100,000. Depends on the time of the day. So this is different data like in-app purchases, like advertising data, what the user clicked, so all different types of events. Now, how does it all happen? What you see on the screen is our data ingestion pipeline. So this uses all the components that the guys before me explained, like Google Cloud PubSub, Dataflow. Before that, before BigQuery, we were doing game analytics, but we did it in a really primitive way. We had some sharded counters in Google Cloud Data Store. We used to parse logs and dump them into SQL databases, so that really didn't scale. Also, we tried using Google Analytics, and again, that didn't scale at our pace and didn't provide the features that we need. So this is what we came up with then. So when BigQuery came out, this was a real lifesaver for our game analytics. So on the screen, if we go from the right to the left, so mobile client sends some events, and this is received by a REST API endpoint running on Google Container Engine. So that does some basic validation and stores the event in Google Cloud PubSub for later processing. And then we have a Dataflow job on your left. So the Dataflow job takes the event from the Google Cloud PubSub, does some extended validation, does some enrichment of the events before writing those into BigQuery. And then when in BigQuery, we have some business analytics to analyze that data, and also we have some data scientists that also explore all the data that we gathered. But it's not just the client events that we're collecting, we're also collecting events from our mobile backend. So we have a backend also running on Google App Engine, and we're generating events on Google App Engine and sending them into pull queues. And then again, a data flow processing job takes those events from the pull queues before inserting them to BigQuery. And again, they are available for further analysis. Why do we use this pipeline? From a technical standpoint, it's a really good pipeline. I can tell you that from my personal experience because I work with this every day. So one thing is flexibility. You may think there are a lot of blocks just to get the data inside the BigQuery. But really, this is very flexible because we can do upgrades for individual components and not affect the other components. So this really makes an effective pipeline for us. And also, we can scale each and every component separately. So for example, if we need to do even a stronger enrichment, in the data flow job, we add more nodes. So we just scale on the data flow part, and we only pay for that data flow part. If this was one big box, and we would want to scale, we would need to scale the whole big box. So that would cost more money. So yeah. And also, the high availability is really good. So for example, if BigQuery goes down, the events are still stored in Google Cloud PubSub. Now, the BigQuery doesn't go down often, but it can happen. So this is a very good design to avoid failures, because you still have events sitting in the Google Cloud PubSub, and when BigQuery picks back up, then also the data flow job restarts and picks back up where it left off. So really good pipeline. And if you're familiar with microservices way of designing things, those are all the things that come under the hood of microservices. So what do we do with this data? So I'm going to present actually two charts. What we're analyzing, what is our business benefit from that. And the first slide shows a number of application installs during the days. So there's no surprise. You see the blue bar shows how many installs were there in a day, and you see that the highest bars are usually, you can guess, those are weekends. So more players are engaged during the weekends. And the green line shows our rank for the app on the App Store. So these are two charts. One is for Talking Tom Gold Run, and the other is for My Talking Tom. That's still our flagship game. And this is important in mobile gaming installs because it directly affects our revenue. So if you want to be successful in mobile gaming, getting new users, getting installs all the time is really key to the success. So this is very important for the business analytics. So getting more and more installs. And also, rank on the App Store is important. If the rank on the App Store goes down, if not so many users are downloading our app, we can arrange a marketing campaign to acquire new players. So yeah, without this data, this would be very hard to do. And also we have some machine learning algorithms which decide based on the number of installs by region what kind of ads to serve. The last chart that I'm gonna explain is from our multiplayer games. So this shows the distribution of matches in our multiplayer games throughout the world. So we see the darker areas means that in the last 24 hours there were more players active there. And you can see in the gray gray stacked charts below how many players were active in a particular part of the day in a specific country. So we have Russia, Brazil, China, and so on. So we can see how many users were active, but what's important here, maybe more than the number of matches, is the matching time. And this is represented by the line that you see over the number of players chart. So the matching time means that if I started playing a game against another player, it means how long I have to wait for the other player to start playing against me. And if this time is long, it means that user experience will not be that good, and of course, users will not be using our apps. So we want to have the best user experience, and we track things like these matching times. And it's not only the business analysts that are looking at these numbers. We also have this metrics pulled from BigQuery to Stackdriver, and our DevOps team has some alerts tied to these metrics like the matching time. And if the matching time is too high, then they get some alerts and they can check whether the servers are okay and if the infrastructure is running as planned. Now, with this, I will conclude my part. Just to summarize, I think, and so we really think that the Google's analytics platform is really is the key to our long-term mobile success. So with that, I'm going to turn over to Daniel. He'll explain more about data exploration and visualization. Thank you.
Thanks a lot, Mitya. So, as we just said, I can go over kind of your data exploration and visualization. This will kind of cover on your stack, although it's not partial to any particular person, but typically this would be your data scientists, data analysts maybe. Your business analysts are probably more on the visualization side, but this exploration side we're going to review is called a product we have called Cloud Data Lab. Now, there's a lot of key benefits to Cloud Data Lab. It's basically data science for developers. It's a part of the IPython open source project, and you can have IPython notebooks you host on Google Cloud's backend F1 Micro machines or Jupyter notebooks. In fact, at the end of Mitya's presentation, you might have seen he had a Jupyter notebook for one of the visualizations and explorations. You can take that, put it on one of our F1 Micros, and run it locally with the computational power being done by your VMs. It's great because it's fully integrated with our other products. It allows you to enter in Python, SQL, JavaScript into your back-ended connectors to BigQuery, so you can do things like machine learning analysis. So you can have your aggregate data, combine some Python, and just do machine learning that way. This kind of goes over the connectors we have: BigQuery, Dataflow, Data Lab, Dataproc, machine learning, and so on. And these can be output into visualizations, as I said, machine learning models, batch streaming pipelines, metrics and dashboards, and ingestions and ETLs, whether proprietary or done through Dataflow. And again, what's great about this is it's all interconnected through your authorization, and you can have the ability to use ACLs to have permissions for how people use that data or not, and it's all completely connected. But let's actually look at this. Oh, my demo screen is gone. Let's take a look at what this actually looks like. If you want to switch me over to the demo. That picture again. So right here, all I'm going to do is just go into our Cloud Console. This isn't necessary, but I wanted to at least show you the machine it's using, which, as I said, is just a tiny F1 Micro. I think it runs about a little over $17 a month to run 24/7 for the entire month itself. And we're going to go ahead and just connect into it through our Cloud Shell here. So this is pre-built already, but all you'd really do if you're doing something on your own is the command is just data lab basically create. You put where the region zone is, and you're off and on, ready to go, and you're naming it. I'm also going to do a no user check, only because this is connected. I made this account this morning associated with my Google account, so I don't want you guys to be able to see that. So you'll see it tells me, my bottom left pane here, to use port 8081. And now I'll have a local environment connected to my Data Lab notebook. Now I already have, and you'll see this consistency with this data set we have for gaming. The one Joe was showing for storage in BigQuery will be the same data set I have for this Python notebook, and the same one that even Colin will be using for Looker's presentation. So it's all the same data set. And again, it's the whole entire imagery we want to show you that you can use any kind of data you want across any kind of platform. And if you choose us, we're happy with that as well. So for here, if you do this yourself, you would just create your own folder or create your own notebook itself, and you can upload it directly from your local environment. In my case, I already had done that. And we'll take a look at what it says. So here's just a simple little print hello world. But let's say we want to do something like find out insights about daily active users. And our data scientists, before we get this to our data analysts or business analysts, we want to figure out what's the source of truth of how we're going to do this. And we want just a little visualization. So it's still the engineering mindset where we're looking for functionality over form. But what's great about this is you'll see this query I'm running. This is connecting to that. It's connecting back to our BigQuery backend. The query is already complete by hitting run. And I can just do a little MATLAB plot of what this chart would look like. Okay, so we're in trouble. For a daily, I kid, but this is of course the visualization of what this look like. We can go here and take a look at our trend and our users and so forth. And as I said, this game needs investors. Daily sessions, if you want to do that, it's the same process. We're going to take all these select commands and SQL-like commands are calling directly to BigQuery. We'll run it. The query is already complete. And we'll do another plot of that. Now, within this, you don't have to do necessarily these plot out graphs if you maybe aren't familiar with it or you just want to use your simple BigQuery commands. So I can do this here and just have it show what would have been in BigQuery if I want to stay in the same dashboard in this case for top session duration. And it'll spit out how this table will look like. And there you go. Now that's really interesting information for like user acquisition or user information, but if we want to find some telemetry about like tweaking our game, seeing if there's a difficult boss or if there's something we can tweak on a level or whatever, we'll do the same thing, run a command right from our environment here, plot it out, and we can start having insights with quick visualization. Looks like boss 10. Looks like this is a Dark Souls game. Okay, so switch back over to presentation. Moving over from there, often we have quite a few business analysts and data analysts that want to see a more robust visualization platform because that's more made for analysis, as I said, function over form. And we have this great initiative called Analytics 360 at Google. We're trying to connect all of our different platforms we have, so YouTube Analytics, Analytics, as Mitya said, he was looking for a scalable solution for that, BigQuery, all these different solutions, connecting together on one platform, and we're accomplishing that with Data Studio. It's great because I'll show you a demo, but you'll be able to securely share reports, and it gives you actually spit out reports. So instead of sending like an email or a sheet or a Tableau or whatever it is, however you communicate this all together, you can communicate on an authorized, secure system and share it to each other on these full reports in one platform. It's UX, UI for data essentially, and you can have multiple source ingestion. These are all the things that it connects to. I think most notably is MySQL. Yes, you can connect to your on-premise MySQL environment, and all these different products for Google connect together. So let's actually take a look at what a demo looks like for this. Switch me over to demo. Oh, you did. Okay, so all I did here is I went to Data Studio, to Google.com, still in the same authorization of where I logged into. And at the top here, we have reports. There's some templates if you want to use a template in case you're not a great artist, which I'm not, and you'll see this in a second. Or if you want to use your own sources, you can come down to data sources. And right here, it just kind of gives you a log of reports you currently have. Also, when you sign up for this, it's great because you look at the very bottom where it says, welcome to Data Studio. The actual report itself is a tutorial as well as an interactive report that shows you how to use Data Studio, so it's pretty innovative that way. So let's just see how this would be if I were able to do this and make a great visualization thing. It's not me, but you can go to data sources. On your bottom right here, select your data sources, and there's all those different products we just talked about. Now, our consistency was this BigQuery data set, so we want to show you how you click here. The project was called Gaming Demo from my cloud project, and we were on game events. In this case, if I want to bring in, events, that table itself, you just hit connect. And then you have an idea what your table will look like. You're still able to, if you want, create new calculated fields if you want to add on to this, or you can change the type, aggregation, and put description in case you want to have like notes to each other and how you change this. Once that's done, you simply create the report. And now everything back-ended that was done by your data scientists, data engineers that are connected to any of those platforms that you went to now has insight based off the dimensions from that. So this is just a bar graph, for example. And you can see from the events data table, we have data for session start time as our date range dimension, and our event ID as our dimension. Now these can all be changed, obviously, and you can select different dimension sources and style for how it looks like. So we're gonna do a bit of a cooking show here and put this in the oven and come out with what this would look like if we had put a lot of effort into it. So I have a report pre-made, and to switch it up a little bit and to give YouTube Gaming a little bit of branding here. In this case, we were saying, what if we want to find out how our channel did for YouTube Analytics for the YouTube Gaming channels? I don't know if anyone knows, but if you go to gaming.youtube.com, we have an entire UI and wrapper, as well as some features for gaming type of video platforms. In any case, this is all directly from that source. Someone's made this very pretty demo already for us, and it's fully interactive. So in this case, I was looking at my insights from February 8th to March 7th, but let's say I wanted to dial it back and look through March 1st. You apply it, it's already updated in the back end, it just calls to it, and you'll have new insights for your visualization. And again, what's great about this is this report, all I do is share it to someone else. So if I want to share it to Joe Hawley, my peer here, well, I won't put it all out. I can hit there, share it to him, give him edit access, view access. Have the same advanced functionality you have with Google Drive or Sheets, which I'm sure most of you are familiar with, and he'll be able to have the same interactive report to share as opposed to having like a simple deck you share and say this is what it looks like with no kind of insight. This is consistently connected to a back end. So in this case, if we're looking, we can see that the United States is our most views for this particular channel. Wisconsin is our second most, West Virginia, and so forth. Now, this is one of our great visualization tools that we are really building a lot more onto and more integrations. But if you wanted to use something you're familiar with, like Tableau, we just saw Mitya mentions that's what he uses. But if you want to use something else, we're going to have our strategic partner come on stage here, Colin, who's going to show us how he uses Looker in cohesion with BigQuery.
Thank you. If we could jump back to the presentation. So hopefully you guys have taken away a few different things from everyone that's talked so far. So one, all of the Google pipelining stuff really makes managing all of this data a lot easier. You really can track everything now. You can pipeline things really easily. There are managed services that make tracking way easier than it's ever been. Two, it can handle really, really large data sets. So where you might have thought about metering data or having an incrementer to count things, now you can put billions of rows into a BigQuery and get at it very easily from a SQL runner or a BI tool. So where Looker kind of approaches this problem is where lots of other BI tools in the past have been built around data pipelines and databases that were row stores or even columnar stores that were a little bit less performant. When these services like BigQuery came out that can separate compute and storage, you really can run very enormous queries. You can query 20 billion rows of data and actually get results in seconds. And so that means that you need different BI tools to sit on top of these things, where tools in the past might have pulled out portions of data or tried to aggregate data to return analytics. Now there's just no need to do that. So Looker really approaches this problem from completely blowing up the way that BI was done and live connecting to all of your data. So do all this great pipelining with Google, and we can sit right on top of it. The next thing that you should kind of take away from all of this is there's a lot of different ways to do analytics on top of your data. There are data scientists that want to write raw SQL and script and do machine learning on top of things. And there are very non-technical people that want to visualize data, pull reporting, ask questions of data without having to understand SQL. So as you build your tooling, you really do want to think about balancing all of those different users. And we're trying to strike a balance with all of those different things. So a couple key takeaways that I would love you to remember about Looker and just about how we work with things. One is that we're deeply integrated with BigQuery and the Google Cloud. So you see things like cost estimators and size estimators of queries. We deeply integrate those into the product because, again, when you're building a new way to do analytics on top of these things, where another tool might live connect, if you can't do cost estimation or kind of these super features like nested data structures and things like that, you can't take advantage of all the interesting stuff in the database. Secondarily, we have deep support for everything that Google's doing. So Google released Spanner 2 weeks ago, and that's already supported in Looker. So as you adopt new technologies, again, because we're dependent on these databases to build good stuff and fast stuff, we're adopting them just as quickly. So that's something that's really important to think about as you build your analytics stack. Second, the real power of Looker is we're writing raw SQL to the database, so we're taking advantage of BigQuery, but all of this is mediated through a model that's holding all of your centralized definitions. So for people that want to write SQL, there's all of that power. You can get at the raw data. You can sculpt queries in a very custom way. For people that want to point and click and use kind of a Tableau style interface that might not ever want to interact with SQL, we've got that as well, and that's all stored in the data model, and we'll show you that in a second. And then lastly, because we're sitting on top of all of the data, you can do roll-ups and high-level metrics like daily active users and things like that, and you can get down to row level. Before I jump into the demo, the last thing is the power of this data model lets us bring customized understanding to different types of data sets. So this is about gaming analytics, and at some level, all of the things we've done so far are kind of arbitrary analytics questions, counting users, doing things. The nice thing about this model that we have in between is that we can actually go and create understanding of different types of businesses that are immediately installable on top of your data. So if you're recording data in specific types of ways, right out of the box, we can connect and do things like daily active users and things like sessionization and progression analysis and fraud analysis. So just remember to record everything, and then kind of we'll get into how you guys can take advantage of that. So if we could switch over to the demo. So first, to kind of just go back to exactly what I was saying, we have essentially a marketplace of all of these different types of analytical patterns on top of data sets. So as you're recording data, we have different ways to integrate analysis on top. We have a gaming block for gaming analytics, and we're going to get into that a little bit. So this is Looker, kind of a very typical dashboarding tool as you'd expect. We've built a bunch of dashboards on top of that same gaming set that we were playing with. So let's go take a look at what these types of things look like. So these are literally just running queries to that same BigQuery data set. So behind each of these individual tiles is a query in BigQuery. So this 52.61% completion rate kind of that we talked about, we can go look at the distribution of these things if the internet will come back. But for example, we can look at the user count at each quest level, and we can see that there's a lot of people stuck at level 10. So if I'm a gaming company, this is really valuable for me to understand. As you can see, this is a fairly smooth distribution, and that's what you get with simulated data. But what the beauty of this model on top of this data set lets us do is we can actually go and explore this data more deeply. Sorry. Frozen here. So let's go look at this gaming data set. And we'll go look at events. So again, we're sitting on top of the raw data set here. So as I add fields, we are going to actually be running SQL behind the scenes. So for some people, they might be able to read this and understand it. For some of you, it doesn't matter, because all we're going to do is write queries. But again, the power here is that we're taking advantage of all the good stuff that Google's doing behind the scenes. So you'll note that we're going to process 36 gigs for this query, and this is just going to run in BigQuery. And this is actually running live in database. So as latent as your pipeline is, they talked about a 1-second pipeline, we can hook up to that data and actually query it in real time. So, sorry. So this took 13 seconds to query those 36 gigs of data, and we've got a bunch of raw data. So what that lets us do is actually explore this type of data in real time. So let's go browse for some stuff I made already. But let's look at what's happening on level 10 to see if we can actually understand why users got stuck there. So first, let's look at damage rolls. So this is just a fake demo set. We're looking at, again, all this stuff live. So we're querying the database, and I just wanted to take a look at comparing level 9 and level 10, since we know they look so different. So we can actually see that the damage distribution looks fairly even. And again, I'm going to keep emphasizing this, but this is all just running directly in database. So we're writing the SQL here. The user doesn't need to understand anything, and this is all mediated with a model. If we want to actually dig into level 10 and what happened, we can create these metrics in the back end. And actually, I discovered this earlier, but it looks like we kind of arbitrarily made the boss of level 10 substantially different than the rest of the other bosses. So level 9, our boss has kind of low armor and all this stuff, and then suddenly our boss gets really hard. So again, none of this is rocket science, but because all of this data is so queryable and so easily accessible, all of this stuff comes right out of the box. And all of this is mediated with this data model. Sorry. I'm really struggling here. With this data model that's writing raw SQL. So again, the key takeaway here, record everything, take advantage of these really heavily managed services, and then make sure as you're putting tooling on top of it to think about what you want to take advantage of in that pipeline, whether it's latency or depth of explorability or interactivity for your users, and try to learn from models that you've seen elsewhere. So with that, I'm going to kick it back to Daniel to close it out.
Can you switch back to the presentation, please? Thanks, Colin. I know he wanted to say it, so I'll say it for him. He was using my Windows laptop, which he's not as familiar with, so we forgive him. So just to close out, really appreciate you all coming out. The biggest message, if you could walk away from this, is that we have a lot of managed solutions that take care of your backends, whether it's analytics, game hosting, things we couldn't go over in this session, but other sessions we will be able to go over. Fully managed solutions that handle your day-to-day operations, your back-end operations, and let you get back to being creative and making game, which is what everyone wants to do for game development. We have a completely open ecosystem. We support having your own proprietary technology, third-party partners, whatever you'd like, whatever makes you most familiar, to use our engineering to make you make the best games you can. On the third floor, if you go upstairs and all the way down to, I guess, south, we have a gaming booth, and we'll have 3 games that run our platform. Most famously, Niantic's Pokemon Go, which we all know of, which is a great use case. We'll have people there explaining how it runs and uses our entire stack, almost our entire stack. We have Titanfall 2, which uses a middleware solution called a company called Multiplay, and also has a middleware technology on Multiplay, and they do their game hosting for some of their hybrid cloud for our environment for the game Titanfall 2. And you'll also be able to play it, so that's the most biggest takeaway, right? And then we also have one of our strategic partners who actually has a session tomorrow at 3:30 that goes over, their partner is called Improbable. They have a technology called Spatial OS, which is a distributing operating system that infinitely scales and allows for persistent and stateless worlds that they back end on our technology. And there's a game that's built on that technology that you'll be able to demo and learn more about. Colin also has a booth. Where is it at?
First floor.
First floor. First floor. On the first floor? Yeah, you go.
Yeah, we've got a bunch of books there also. Our founder wrote a book about doing analytics. So if you want a free book, go grab it. And sorry for forgetting the plug.
Giving away free books, folks. So with that, if you have any questions, we welcome it from any of us. Please come up to podium and ask us, and thank you for your time.
Hi there. A nice talk. Just a quick question about the architecture diagram of Output 7. Yeah, Mika, I guess. So I noticed the disparity between, the app engine and PullQ aspect, and then the container engine and PubSub. I'm just wondering if you can speak to that disparity. Was that just the way it evolved, or there was a...
Yeah, so it evolved over time. So what I showed is the latest iteration of our design. At the start, what we did with when BigQuery came, when we received the event, we did all the processing on Google App Engine, and also we did the insert on Google App Engine. From some stuff, we used task queues, but that just offloaded it to another Google App Engine instance. So basically, it was all App Engine at the start. Then we evolved into, we started using this pipeline. Actually, this is a standard Google gaming reference architecture. So.
Okay, thanks.
I kind of had a similar question, but to drill more into it in the sense that you have the task queues for your App Server game engine, and you had the API specifically for client requests feeding the PubSub. And I was wondering, was there the potential for a unified approach of just writing directly to PubSub and doing all your transformation and your validation in data flow, other than the issues of obviously you're getting some efficiencies in micro-batching and you didn't want to handle security on the client, other than those two issues?
Very good question. So yeah, we considered pushing all to PubSub, but at the moment we're using App Engine standard, and for PubSub there's only the REST API client available, which has a higher latency than the gRPC client, for example. So task queues are really fast. So that's why we still prefer to use task queues for that example. So, but yeah, we had to write our own PullQ source for data flow. Because there's no...
Or also even replacing the API endpoint and going direct to PubSub there too.
The API
The client API, the rest.
So
the container service one.
the container service is just for the ingesting the client events. So the server events are generated by the Google App Engine backend and pushed to PubSub.
So about having the API point, you can eliminate that if you want, but almost every customer that
yeah.
I've talked to chooses not to. One, because you can usually keep the costs pretty minimal on that, and two, because it gives them a place to ingest where they can do basic validation and make sure that like people aren't sending events from non-clients and like spamming your analytics pipeline or something like that. It allows you to do a lot of that sort of stuff.
You could do that in data flow. I was trying to
Yeah,
get rid of
you
like
could.
unless everyone's building that custom API
Right.
endpoint now.
Yeah.
Right.
And I understand the core issue of not wanting to manage security on the client of writing to PubSub too,
Yeah.
and
Right.
potential micro-batching, but okay.
Yeah, there's some advantages to eliminating them earlier in the pipeline so that they can't continue down and generate more resource usage and further products.
Might you
past
just
the ingested
make that a
point.
service at some point, like a pre-PubSub?
I like your idea. Come talk to us.
I mean, I understand your question now. Sorry, I really didn't get it before. But the main point is security for me. I wouldn't allow our remote clients, I wouldn't give our remote clients a Google service account to
Yeah,
use
you gotta go
directly
federated or something.
PubSub.
It's still messy, yeah.
Yep.
Thanks.
Yeah.
On that question too, tomorrow we can talk more after we do some more product announcements. We might be able to better address that.
Yep. Go ahead.
Yeah, I have a question for Colin. Yeah, so you just showed us some very beautiful and powerful dashboards.
Yep.
I wonder if you guys build it by yourself or use Google's tools.
So all of our visualizations are homegrown. You can actually install your own visualizations into Looker kind of as desired, built in D3 JavaScript, kind of open source libraries.
So you built use JavaScript or D3, something like this?
You can if you want, and we have our own library as well.
Okay. Because we are using some Kibana and the Elasticsearch stack, so we are trying to looking for similar Google tools, but
Yep.
seems it does not exist.
Yeah.
I just wondered if you give a sense for the cost of some of those BigQuery queries, like maybe the larger ones. Are we talking cents, dollars, tens of dollars?
So BigQuery only charges for what you store and what you actually compute.
Right.
It's hard to say for each one of them, but
So when we query stuff, I think the cost comes up every time.
Yeah, I
Just
wanna
curious roughly, like
I
some of those larger
believe
queries.
it's $5 a terabyte.
Yeah.
oh,
yeah,
sorry, I
it's
thought you meant
five-
those specific. Yeah.
The queries you were making, were
Yeah.
they cents, dollars,
Yeah.
hundreds of dollars?
So
Yeah, you're right.
$5 a terabyte means that 30 gigs is 20 cents.
I get that.
Yeah, that's a really good point. If any of you use that UI, you're actually going to get a little cost estimator of how much it's going to cost based on the amount of data it's querying. We were logged into a Google account, and it hides that for us
okay.
by default, and we didn't turn it on for
Okay,
the demo.
okay.
That's all that is. Yeah.
Other question is, I didn't see Bigtable mentioned anywhere. Was that in your consideration?
There's case for Bigtable. I mean, more importantly now, Spanner, that's global availability. There's a lot of cases, but we didn't mention within this particular pipe. And something I want to talk about BigQuery too is we have quite a few cost control mechanisms in our ACLs too, where you can get very fine grained as far as calling if you can or can't do a join or something like that. So if you're worried about someone on your team, and data scientists running up your bill, you can put those cost controls in place. So it's helpful too. And we also have packaging too with BigQuery for if you run a lot of queries, you can do a certain package, or you can do with a typical model we have too.
Yeah, we do have a couple of game customers who do run analytics load on BigQuery. And mostly it has to do with specific things that they're trying to do. For the vast majority of customers, we recommend BigQuery over Bigtable, mostly just because it takes care of all the management part for you, whereas Bigtable does actually have nodes that you need to add in order to meet higher IOPS thresholds, and being able to query it or insert more data into it requires more nodes. So there is a management component there. If you're willing to take that on, it can be a really good analytics solution as well, yes.
It
Yeah,
also
thanks.
depends on your use case, because Bigtable is read and write, and BigQuery does not have that sampling functionality. So, for Bigtable, yeah.
I have a question about BigQuery. So one of its advantages.
We can't, if you come a little closer to Mike, yeah.
A question about BigQuery. One of its feature advantages is it's real-time ingestion. So real-time reporting doesn't mean just that I can report as of this minute. It means that it should refresh. You know, I should have a tool that it refreshes every 30 seconds or every minute. Right. So I can just watch how things are progressing. I don't have to press, refresh. So does Visual Studio, Data Studio, does it have a...
Yeah, Data Studio is going to be authoritative to what your backend is. So in that case,
Sorry?
our backend in that case was from BigQuery, or the data set was from BigQuery. So whatever's happening on your backend will be mirrored in your front end for that case.
So you can you can create a dashboard and set it to refresh every minute?
It was just a question about live refresh.
Yeah, like
Automatically.
Right. It's whenever you're calling back to it, it's going to call back to BigQuery itself. So that there's no need to set anything in Data Studio for that to happen, as long as it's set within BigQuery. Is that what your question is?
No, that doesn't make
Just
sense.
can the dashboard auto refresh?
Yeah. Yes, the dashboard will auto refresh on your reports.
As like every minute, for example?
I don't know about the actual time settings for Data Studio itself. Yeah.
Because I think that here the question is more regarding like a dashboard kind of a product,
Yes.
like Gecko
It's not
board.
BigQuery, it's dashboard, exactly.
For what it's worth, you can do that in Looker.
You could do that last year. Actually, I checked that. Yeah. So on that, I have a question on that, and that's, do you have to create models? Do you have to create because that is
Yes.
time-consuming.
So yes, you do have to create one. We'll create one automatically for you. So all of those blocks that I showed you are essentially automatic data models. So we're going to generate an automatic data model when you connect, and that's just going to let you use every column as a field, kind of a trivialized data model, and you can embellish that as desired.
Okay, got it.
I have a question about Google Data Studio. As far as I know, it's still in beta, right?
Yes, it's still in beta, correct.
And in Europe, we can't really play around yet, so we can't try it out. Any idea when it's going to be full released?
I don't, and their product manager for that, I wouldn't want to speak on their behalf. If you can come see me after, I can connect you two together. He or she might be here, actually. It has cloud functionality, obviously, but it's an analytics product we use to show for visualization. So let me connect with you after, and we can talk about that.
Great. Thanks.
And for your question, too, if you want to talk after, I still feel I didn't quite address it, so I'd like to talk to you as well with Data Studio.
Okay, I have one more question, please. does it can it Data Studio can it connect to other databases that have JDBC or ODBC drivers?
I'm not sure. I know whatever we have listed for MySQL would be the most like on-premise solution you can use for that.
Yeah, I think it's just MySQL and Postgres right
Yeah,
now.
MySQL, PostgreSQL, and then the rest are all essentially Google products. We got 10 seconds till we gotta, yeah.
Okay, quick question. So let's say you're using BigQuery to even record events like sales, in-app purchases, right? Have you had any issues with deduplication, of events going into BigQuery?
Excuse me, replication?
No,
Deduplication.
Deduplication.
Oh, deduplication. Yeah, so deduplication, it's part of it is carried by the data flow job, by the PubSub ingestion. So the PubSub source has a support to deduplicate records. And also when you write to BigQuery, the BigQuery streamer that's used in Google Cloud Dataflow has also deduplication on its own. It's not that good as on the PubSub source, but it still gets a lot of dedupe done. In general, Google takes care with their SDK or APIs for that.
I'd add that analytics tools can add a third layer to that. So analytics tools can do some of that deduplication as well.
All right,
Thanks.
thanks.
Will take care of most, yeah.
Thanks, everyone.
Thanks.